What up? Today we are going to be taking notes on classifying real numbers. You guys have done classifying before. Last year in seventh grade science, you guys classified animals, you talked about the different families, you talked about the different phylum, and all that stuff. You guys classified shapes last year with us in math. We classified the different types of quadrilaterals into trapezoids and squares and rectangles and parallelograms. You guys classify all the time. But now we're going to be classifying numbers. So, what classifying is grouping things together. If they are similar. We're not just going to group everything together, only if they have similar characteristics. So, like we said, some examples of classifying. We've done parallelogram or quadrilaterals, excuse me. And then you also did, like we said, you've classified animals. Like there's the mammals, there's insects, there's birds. You guys have classified lots of things before. So in math, we have this chart that kind of helps us see where numbers go and how they relate to each other. This innermost group, these are called the natural numbers. When you think about natural numbers, I want you to think about counting numbers. Think about counting numbers. Like 1, 2, 3, 4. If I can count to it, it's a counting number. So, like we said, an example would be 1. An example would be 57. I can sit there and I can count. Eventually, I'll get to 57. Another example of a natural number would be 10 over 2. I don't count to 10 over 2, but what does 10 over 2 equal to? 10 over 2 is equal to 5. So sometimes I might have to simplify before I classify. Simplify before you classify. So those are my natural numbers. The next step up, we have whole numbers. Whole numbers. Whole numbers, as you can see, natural numbers are inside of whole numbers. So all of my numbers that are natural, they're also whole numbers. There's only one number that's different. There's only one number that is whole but not natural, and it is the number 0. The way to remember that is the letter O in whole, and that's where we see the number 0. So again, whole numbers are natural numbers and 0. We just add that one more number and that makes it a whole number. So it's 0, 1, 2, 3, 4, and I can keep on counting. Our next one out are integers. You guys have seen integers before. We've talked about integer operations before in math. We've talked about integers on a number line. So when you think integers, think numbers on a number line. What kind of numbers do you see on a number line? Positives and negatives. So there's a bunch of numbers. I'm not going to start at the very beginning because I can't. But I'd have like -3, -2, -1, 0, 1, 2, 3, and I can keep on counting. So integers include the negative numbers. So let's have like a -5 and a -7. Again, if I look at my chart, here is my line for integers. Here is my line for integers. Everything inside of that blue circle for integers are still integers. 0 is still an integer because it's inside that integer bubble. 57 is still an integer because it's inside that integer bubble. Let me do the same for the other ones. Again, whole numbers include my natural numbers because the natural numbers are inside that green, that whole circle. Natural numbers, again, these are the very basics. If it's not one of those counting numbers, 1, 2, 3, 4, 5, 6, so on and so on, it's not natural. And then the last group are our rational numbers. Rational numbers are when we see, so all these other things, so it's integers and whole numbers and natural numbers and fractions and decimals that do not let me rephrase that. So decimals that repeat. Decimals that repeat or terminate. We talked about that word terminate a little bit before when we talked about square roots. Remember that word terminate means end. So these rational numbers, these rational numbers include all these other numbers that we've talked about before. Most of the numbers you know are rational numbers. So again, like I said, I'm going to start seeing fractions in here. So I'll see like 3 over 7. I'll see 11 over 3. I'll see decimals that repeat. So like 0.7 repeating or 0.12, and both the 1 and the 2 repeat. Or a decimal that ends, that terminates, like 0.5. That's it. It stops. It ends. Those are rational numbers. So again, rational, that orange circle, includes integers, whole numbers, and rationals because it's all inside that bubble. It's all inside that bubble. But then we've got this little bubble all on its own, these irrational numbers. I know my tone kind of changed a little bit, didn't it? Irrational numbers are numbers that have decimals that do not end. They do not. They do not repeat or terminate. Irrational numbers have decimals that do not repeat and they do not terminate. Like we said, the word terminate means end. The word terminate means end. So some examples of irrational numbers that you've already seen before would be like the square root of 7. I know it's between 2 and 3, but that decimal, it just keeps on going and going and going and going and going. It does not end. It does not terminate. It does not repeat. It's just a really ugly number. If I have the square root of 11, that number does not repeat. That number does not terminate. It just keeps on going and going and going. It's really ugly. It's really ugly. There's a few famous irrational numbers. one of which I know you guys have heard of, pi. Pi is an irrational number. It's a decimal that does not terminate and does not end. Computers have been calculating it literally longer than you and I have been alive, and they still have not found the end of it because it's irrational. There's another number that's irrational that's kind of famous. You guys probably won't get into it for a while, but it's the letter E. E is a letter and it's a number, and it is an irrational one. When we look at the irrational bubble, it's all by itself. Numbers are either rational or they're irrational. That prefix IR means not. So numbers are rational or they're not rational. That makes sense. But all of these numbers, whether they're rational or irrational, all of these numbers are all considered to be real. All of these numbers are considered to be real. And what that means is basically we can do the math to get these numbers. We can do the math to get those numbers. There's no problem to calculate them. When you get into algebra, you'll learn that there are imaginary numbers. Numbers that we know how to do the math for it, but the math doesn't make sense. The math doesn't work out. And so you'll get into imaginary numbers later. All right, let's go ahead and pause and take a break, and we're going to come back and do a few example problems together. All right, you might have seen and thought to yourself, what is Miss LaRosa talking about up top, where I said the real number system is like toothpaste. You guys are probably thinking I'm a little bit crazy for saying that the real number system is like toothpaste. Think about toothpaste. When you squeeze it out, can the stuff that comes out come back in? Not really. You can try really hard, but you can't really do it. When you think about the real number system, think about these numbers like toothpaste. A natural number can squeeze out and it can be whole. A natural number can squeeze out, it can be an integer. A natural number can squeeze out and it can be rational number. But can an integer squeeze back into the toothpaste and be natural? Mm-mm. Can a rational number squeeze back in and be a whole number? Mm-mm. It's like toothpaste. The numbers can go out, but they can't come back in. The numbers can go out, but they cannot come back in. So think about toothpaste when you're working through these problems. So for our examples, it says, what are all the sets for the following numbers? All the sets that it can be. Think about the toothpaste. So 0, I want to think about it like toothpaste. I want to start at the middle and see if it's there. Because once I figure out its lowest level, I know it's everything else outside of it. Is a 0 natural? Mm-mm. Is 0 whole? Yeah, that's the first place that the 0 starts, is that it's a whole number. And then because it's toothpaste, it's going to squeeze out. So a 0 is a whole number. It's an integer, so I'm going to write an I, and it's a rational number. Remember, everything that we've talked about, every number you've heard of so far is real. So on the test, if they ask you if it's a real number, the answer will be yes. The answer will be yes. Moving on to 1/2. Moving on to 1/2. Is 1/2 natural? Nope, I can't count to 1/2. Is it whole? It's not a 0. Is it an integer? It's not on one of my number lines. Is it rational? Yeah, rational is where I start to see my fractions. So 1/2 is just rational. 0.3 repeating. 0.3 repeating. Is it natural? I can't count to it. Is it whole? It's not 0. Is it an integer? It's not on my number line. Is it rational? It's a decimal. Remember, rational numbers are decimals that repeat or terminate, that end. Does this 0.3 with the line on top, does that repeat? Yes, it does. So that is also rational. Number 4. Is number 4 natural? Yeah, I can count to 4. You can count to 4 so well. So that means if it's natural, we toothpaste it out. It's also whole. It's also an integer. It's also a rational number. Okay, the square root of 25. I'm going to have you try this one on your own. Cough, cough. Cough, cough. The square root of 25. What is it? The square root of 25 is equal to what? It's equal to 5. Simplify before you classify. Use your calculator to help you if you need to. So now I want to think about really the number 5. Where would that go? Natural. Toothpaste it out. It's also whole. It's also an integer. It's also rational. A lot of people see, oh, it's a square root. It's irrational. Square roots are irrational. Not all of them. You've got to simplify it. If it's a perfect square, like 25, that's a perfect square, I can simplify it so it's not actually irrational. All right, we're going to pause. I want you to try these bottom 5 all on your own. I'm going to give you guys 2-3 minutes. Pause the video, do those 5 on your own, check back with me. Try to pause this down there on the screen. All right, the square root of 8. That does not simplify. The square root of 8 is irrational. And that's it. Because irrational, there's nothing to toothpaste out into. Negative 0.09. Not natural, not whole. Integer, it's negative. I'm not going to have a decimal point on a standard number line. Negative 0.9 is going to be rational. The square root of 121. Simplify. I get 11. Where would 11 go? 11's natural, and I toothpaste out. So natural, whole, integer, rational. I should put IRR so we know it's irrational. IRR is for irrational. Negative 2. Not natural. I can't count to negative 2. Not a whole, not a 0. Integers, it's a negative on my number line. So that would be an integer and rational. And then negative 6/2. Simplify before you classify. Negative 6/2 simplifies to negative 3. Where's negative 3 at? That's an integer. So that means it's also rational. Okay. I hope you guys understand this. And if you don't, that's totally fine. Get some practice, use your charts, and let us know how we can help you. Good luck.